All right, welcome. In this explainer, we are going to get you totally comfortable with density. It's a super important concept for your O-level physics exam, and we're going to break it all down, from the big ideas right through to the hands-on experiments, so you can absolutely crush those questions.
So, to get our brains warmed up, let's start with a classic physics puzzle. How is it that a massive 200,000-ton steel ship can float, but a tiny little pebble sinks right to the bottom? It just feels wrong, doesn't it? Well, by the time we're done here, you'll know exactly why that happens.
Okay, so here's our game plan. We'll break this down into 4 parts. First, we'll cover what is density. Then, we'll jump into the math with the density formula. After that, we're getting practical with measuring density of solids. And finally, we'll look at measuring liquids, and I'll give you some crucial exam tips.
All right, section 1, what is density? At its core, it's all about the relationship between mass and volume. Let's kick things off with a really simple visual to make it clear.
Okay, check this out. This visual really nails the concept. See those 2 boxes? They're the exact same size, right? So they have the same volume. But look at the one on the right. It's crammed full of particles. It's got way more stuff or mass packed into the same amount of space. And that's it. That's what being more dense means.
And that leads us perfectly to the official definition you've got to know for your exam. Density is the mass per unit volume of a material. Or, to put it simply, it's just a number that tells you how tightly packed the stuff in an object is.
This table really helps put things into perspective. Just look at the numbers. Air is super light, right? Only 1.3. But then you jump to lead, which is over 11,000. And the really important one to remember is water, right there in the middle at 1,000 kilograms per cubic meter. That's our magic number. Why? Because if something is denser than 1,000, it sinks in water. If it's less dense, it floats. Simple as that.
Okay, so we've got the concept down. Now let's get to the formula. This is how we turned that idea into actual numbers you can calculate with, which is exactly what you'll need for the exam.
Here it is. This is the big one you absolutely have to memorize. That first symbol, it looks kind of like a curly P. That's the Greek letter rho, and in physics, it stands for density. Then you've got m for mass and v for volume. So density equals mass divided by volume. Super simple, but you're going to use it a lot.
And you know what? Here's a pro tip for the exam: the formula triangle. This thing is a lifesaver. Just cover up the thing you want to find. So if you need to find mass, cover the m with your finger. And look what's left: density times volume. Need volume? Cover up the v, and you see it's mass divided by density. It's an awesome way to avoid messing up the algebra when you're stressed.
Okay, theory's great, but let's put this into practice. How would you actually use this to solve a problem? Let's tackle an exam-style question together.
So, here's our subject, a paving slab. The question tells us its mass is 73 kilograms. Nice and easy, but it doesn't give us the volume directly. Instead, it gives us the dimensions, so we'll have to figure that part out ourselves. Now listen up, because this is how you get every single mark. You've got to be methodical. Step 1, figure out what you know. We've got the mass and we can calculate the volume from the dimensions. Step 2, write down the formula. Rho equals m over v. Seriously, you can get a mark just for that. Step 3, plug in your numbers. And finally, step 4, do the calculation and get your answer. Following these steps shows the examiner exactly what you're doing and helps you avoid silly mistakes.
Okay, so we've got the theory down, we've done the math, but how do you actually find the density of something in a real lab? Let's get practical and start with solids. And we'll start with the easy stuff, objects that have a nice, regular shape. Things like cubes or cylinders. So to get the density, we need 2 things, mass and volume. The mass is the easy part. You just pop the object on a digital balance. To get the volume, you'll need to measure its dimensions. A ruler will work, but for a more accurate reading, something like Vernier calipers is even better.
And here's the step-by-step process for getting a really accurate result. Now pay close attention to step 3. Repeating your measurements and taking an average is a huge deal. It helps reduce errors, and trust me, examiners love to see that you've mentioned it. After that, you just calculate the volume from your average measurements and plug it all into our good old density formula.
Okay, that's great for a nice, neat block. But what about something with a weird shape, like a lumpy rock? You can't exactly measure its length, width, and height with a ruler. So we need a totally different trick to find its volume.
And that's where this really clever technique comes in, the displacement method. The idea is brilliant and simple. When you put an object in water, it pushes some water out of the way, right? Well, the volume of the water it pushes out is exactly equal to the volume of the object itself, and we can catch and measure that water with a special piece of kit called a Eureka can.
Now, the most important part of this whole procedure is step 4. You have to lower the object into the water carefully. If you just chuck it in, it'll splash, and that splash is water that should have gone into your measuring cylinder. That'll mess up your volume reading, which means your final density calculation will be wrong.
Okay, we're on the home stretch. Let's quickly cover how you measure the density of a liquid, and then I'll finish up with some must-know tips for your exam.
With a liquid, getting the volume is easy, right? You just pour it into a measuring cylinder and read the number. But how do you get its mass? You can't just pour it onto a scale. So here's the trick. First, you weigh the empty measuring cylinder. Write that number down. Then, you pour your liquid in and weigh it again. The mass of the liquid is just the second number minus the first one.
You know, whenever you're doing any science experiment, you've got to think about errors. There are two main types. Systematic errors are when your equipment is off, like a scale that doesn't start at 0. That'll make all your results wrong in the same way. Then there are random errors, which are just unpredictable little mistakes, like misreading a number or splashing a bit of water. The solutions? For systematic errors, check your gear. For random errors, take a few readings and find the average.
Okay, this slide is basically your secret weapon for any exam question that asks you to describe an experiment. Seriously, just follow this checklist. Start with the formula. List the equipment you'd use. Explain what you're going to measure and how. And always remember to say you'll repeat the measurements and take an average. Oh, and double-check your units. You do all that, and you're well on your way to a top-level answer.
And there you have it, a complete tour of density. So let's circle all the way back to where we started. Why does that huge steel ship float? We know that a solid block of steel is way denser than water, so it sinks. But a ship is mostly empty space, right? It's full of air. So think about it. How does all that hollow space change the ship's overall density? If you apply everything we've just talked about, I think you'll find the answer floats right up.